There are a whole lot of different types of calculations you can do with equilibria. In this example, we'll be doing a calculation where we have initial conditions, one equilibrium condition, and we're trying to find an equilibrium constant Kc. And the reaction in question is the reaction of nitrogen monoxide plus hydrogen, giving you nitrogen and water vapor. If the goal is to find Kc, we have to have an equilibrium constant expression. And that's set up as usual with products over reactants. And in order to calculate Kc, we need equilibrium concentrations. Right now, we're only given one equilibrium concentration for nitrogen monoxide. But we are given all of these starting or initial concentrations. So we could do a bunch of stoichiometry, some limiting reactant type calculations, and we could calculate the equilibrium concentrations of each other component. But that's a little bit inconvenient, so what we'll do is we'll use an ICE table instead to simplify the process. It's the exact same stoichiometry, but it's a little bit more straightforward to do the calculations. So now that we have an ICE table set up, we have to plug in values that we know. The easiest thing to do is plug in all of our initial values. We have all 4 of them. We also have the equilibrium value for nitrogen monoxide. The last thing that we can fill out is the change section. We can see that nitrogen monoxide concentration decreases from 0.1 to 0.062, which means that the reactants are decreasing in concentration. So we know that the signs are going to be negatives on the left and positives on the right. We know from the stoichiometric coefficients that nitrogen monoxide, hydrogen, and water are all going to be changing by units of 2. And we know that nitrogen gas will be changing by sets of 1. And now we have enough information to calculate equilibrium concentrations for hydrogen, nitrogen, and water. And again, we'll need all of these concentrations to plug into our Kc expression. If you look at the nitrogen monoxide column, you'll see that we have 3 sets of information. And we can rewrite these pieces of information as an equation. Once we have our equation, we can solve for x. And now that we know what x is, we can plug the value back into all of the other columns and calculate the equilibrium concentrations for hydrogen, nitrogen, and water. And now we have all 4 equilibrium concentrations that we can put into our Kc expression. And we can calculate that Kc for this reaction is 6.5 times 10 to the 2. And you'll notice that there are no units on that final answer, and that's because equilibrium constants do not have a unit, even though they're calculated using molarities.